they're kind of introducing us into exponential functions, but they're doing it through sequences. So I can kind of see the relation, but it's just they're just strange. Okay, so Mallory is training for a race. She plans to slowly increase her running during the month of July. On July 1st, she starts by running 15 minutes, and she adds 5 minutes to her run every day. Mallory tries to record how much she ran every day, but she notices she forgot to track her running on several days. Complete her running log for the indicated days. So on July 1st, she ran for 15 minutes. So how long would she have ran for on July 2nd? Is everybody okay with that math? That's some ground-breaking math, I'm sure. Okay, what about on July 5th? How much did she run? How'd you come up with that? Okay, so you just kept adding 5? Okay, that's one option. And what about on July 16th? That would be kind of, I wouldn't want to add 5 that many times. Maybe you do. You think of another way you could do it besides adding 5 every? 5 times 11. Why would you do 5 times 11?
11 days.
Because there's 11 days between there. I like it. So 5 times 11 would be 55 minutes. And we would do what with the 55 minutes? Add it to 35. So 55 and 35 is 90 minutes. And what about on July 30th? How much did you run? I would do this one a different way, actually. Yeah, that's exactly how I would do it. Yeah. Because I know on the next day she ran 165, so it would be 5 less than that. So yeah, there's our, we'll fill out the table for Mallory. That gives you the amount of time that Mallory runs on the nth day in July. Show that your rule works. So think about it. Again, I don't want to just ruin it. See if you can figure out an equation. So in this case, the day of the month would be N, right? Because it could be any day. So you said N times 5. And then? Plus 10. And then how did you prove that this worked? So which day did you like, just show me? You had to pick one. So if I pick the 5th day, that would be 5 times 5 plus 10, which would be 25 plus 10, which is 35. So on the 5th day, it should be 35 minutes, and that looks like it works. If it says show your rule works, you have to like plug in a value at least once, right? It doesn't matter which one you pick. That would be the work there showing that rule worked. Anybody have a different rule they came up with? Everybody came with this one?
Could you do 5 times n minus 1 plus 1?
And where did you come up with that?
Well, at first I tried 5n plus 15, but then I realized it was 5 minutes too much.
Yeah.
Because it started on day 1 instead of day 0.
You follow that logic? Let me write that in a different color. That our natural instinct would be 5n because we're changing by 5 for every day. So we would naturally think 5n and then on day 1 was 15. But she said this was 5 too many, so all she had to do then was back up in to become n minus 1. Yeah, that's the other one that I wanted somebody to notice. What happens if you distribute this? You would get 5n minus 5 plus 15. Do you have any like terms? 15 minus 5, which is 10. Is this the same thing? Either set of rule? Either rule you come up with? Okay, good talk. 3. What was Mallory's average run length during the month of July? And how could you figure that out? So on average, how much did you run on an average day? So what would you, how do you normally find the average of something? Yeah, you could do that. You could add up every minute and then divide by 31 for 31 days. That seems like a lot of work. If I think of a better way, a lazier way, a more efficient way, anybody want to guess? Hey, it's okay if you're wrong. I mean, it ain't the end of the world. Just use some critical thinking skills and try to logic your way. Oh man, that's hard too. I got an even easier way, an even lazier way. What are you gonna do if you graphed it? Man, that would be. I don't know if that would be like harder. I think I'd rather add them up. I think I'd rather add up all 31.
In the middle of the month.
Yeah. Yeah, so what would be the middle day? It'd be what? It's not 15 and a half. If I have an odd number of things, there's always a middle day. If there were 3 people, who's in the middle? You with me? Odd has a middle. Even has you have to split the middle. So what was the middle day? 16. One way you could find the middle is by adding the first plus the last. So 1 plus 31 is 32. Divide it by 2. That's how you can find the middle term. First plus last divided by 2. So it is the 16th, and then you guys said on the 16th she ran 90 minutes. Now, why can we do it this way? Yes, 100%. That's exactly why you can do this. So here's going to be my explanation. Because she increases her run by a constant amount. So what I'm talking about is a constant rate of change, right? Which means it is linear. She will run her average on the middle day. Middle day of the sequence, which is July 16th, which means she had an average of 90 minutes. Can y'all read all my words? I think I did pretty good. Good for me, anyways. This leads to an interesting discovery. What were we asked to find? If we're asked to find the average run length, what's the fancy math word for that? Her average run length. Average. What's the fancy word for average? Oh, no, not slope. Mean. Okay, the mean of this data set was what? What really was the mean this time? Think about another fancy math word.
Median.
It was really the median this time. It was the middle number in the sequence. So the mean is always equal to the median for an arithmetic that's one of my $1 million words. Sequence. Do you guys know this word's arithmetic? I do this every time I get to this. Did you call it an arithmetic sequence? Okay, so how do you know whether to say arithmetic or arithmetic? Because it's the exact same word with the exact same spelling. How do you know which pronunciation to use?
When you're talking about it, because when you know how to say read and you know how to say read.
It's like arithmetic's an adjective and arithmetic's a noun.
That's it. That's 100% it. Thank you. Welcome to English class. When it's used as an adjective, it's arithmetic. When it's used as a noun, it's arithmetic.
It's like saying it's absolutely not.
No, because both those are nouns. So no, it's not like pecan and pecan.
So you got a glimpse into the world.
So this is talking about what kind of sequence we have. Very good. You know, adjectives are what kind, which one, how many? Do you know that? Y'all didn't get to sing Shirley jingles like we did when we were in elementary school. I can tell you about all kinds of parts of speech.
But you didn't have as much.
And that's also true. Is that where you learned what a noun? I bet she's halfway incorporating the Shirley method, because she used to be a 6th grade teacher, and that was like prime Shirley method time, 4th, 5th, and 6th grade. This little pronoun floating around takes the place of a little old noun. I mean, they're all stuck up in my head somewhere. I just gotta. Anyways. To find an adjective, go, ask, get. Where do I go? To a noun or a pronoun? What do I ask? What kind? Which one? How many? An adverb is how, when, where. To find an adverb, go, ask, get. Where do I go? To a verb, adjective, or another adverb. Man, God, yes. Let's see. I know all kinds of stuff because of Shirley method. I'm telling y'all, it's a shame. Y'all don't know what a vowel or consonant is. Forget parts of speech. I mean, golly.
No, I know what those are. I've watched enough. What's that show? Where there's like Valerie White's up there.
Oh, Vanna?
Yes.
The Wheel of Fortune.
Yeah, I know those.
Okay, yeah, that's a good place to learn about vowels or consonants. I saw a trivia question. What are the 6 letters they give you during what's the final round of Wheel of Fortune? Do you know what they are?
It's R-K-S.
That's not K. R S.
L. Ain't there?
There's an L.
Is there a T?
R S T L.
W. Oh, it's like R.L. Stein.
R S T L
N-E.
N and E. That's it. That's the 6 that you get. Anyways, okay. Speaking of which, you need to join the trivia team. We're probably gonna start practicing soon because I told Bibi it'd be after fall break. So you got time to join. Look at this. I'm just spewing trivia out. Okay. Number 4. How many minutes total did Mallory run during the entire month? What do you think?
So now do we have to add all these?
You could, but I'm lazy. I got a different way I would do it. It's not. It's not 465. You really can't. I mean,
We just picked the last day.
This from, no.
no, no. You're not giving her credit for all the other days she ran, for her total number of minutes. Okay. Let's say this. Let's say this. I went and bought 3 kiddie swimming pools. I don't know why this was made. On average, I paid $30 per pool. How much total money did I spend? Do you know how much I spent on any of the pools? No. But you know, on average, I spent $30 per pool.
So if we multiply the average by how many days?
Yeah. Right? That's how an average works. And, oh gosh, okay. Our math skills are lacking. Have I mentioned that? Okay, so it's 2,790 minutes. And how did we come up with that number? We took the average and multiplied it by the total number of days. I had to dig in my brain. It took me a minute. Okay, so now Mallory's brother Isaac also starts training on July 1st, and he keeps track of the number of miles he ran. Each day, he adds 0.2 miles to his run. On July 18th, he runs for 7.6 miles. Okay?
Wait, why did we change it to Isaac instead of David?
Because Mallory Lindsay has a brother whose name is Isaac. Yeah. You like that? I'm making it more relevant. I'm connecting with the people.
How often does Isaac run?
Okay, so maybe it's not as relevant as we'd like for it to be. Okay, if we look at A, how many miles does he run on July the 19th? Yeah, how'd you come with that? Okay. Yeah. What about B part? How many miles does he run on July 22nd? Uh-huh. And on July 15th? Uh-huh. So can you write a rule that gives the number of miles David runs on the nth day of July? This one's harder. Because I can give you a little bit of help on this one if we need to. But I just want to see if you can figure it out on their own. I'm just seeing. This one is harder. Don't be as ashamed in yourself if you can't do this one. Be more ashamed if you couldn't do the number 2. I'm just kidding. Okay, what's your rule?
4 plus 0.2 n.
Man,
Is that right?
I don't know. That's not what they wrote. Give me just a second. Yeah, that would work. How?
Well, I first multiplied 18 times 0.2, and then I subtracted that from 7.6 and got 4.
Okay, so you decided to figure out. Your goal is to figure out how many he ran on day 1.
Yes.
Okay, and so you knew he had increased by 0.2 miles 18 times because he was on his 18th day. So 0.2 times 18, and then you subtracted that from 7.6 to find his starting number. Okay, that's cool. That'll work. Anybody figure out a different way?
That's what you just said.
Oh,
Okay, yeah, that would also work. I like it. Okay, so think about it like, well, I'll just go back. We'll just do them all at once. Can you figure out how many miles David ran any day without knowing how many miles he ran on July 1st? Well, we couldn't yet, right? The way we did it was we figured out how many he did run on July 1st. Let's come back to that. Okay, there was a common difference, right? Because we're going up 5 every time, right? Even though I know that you can't see because we don't have every day listed. But if you think if we had every day listed and we're going up 5 each time, again, this is called an arithmetic sequence. It's when we're adding the same number over and over and over. That's what makes it an arithmetic sequence. Arithmetic sequences have special things. You have to have a starting number. So in this case, what was our starting number of our arithmetic sequence? It is 15. That's where we start. So we call this, they're using 2 different things. I always called it A naught or A sub 0. You guys know, like when you do slope formula, y2 minus y1 over x2 minus x1, that's really x sub 2 for your second x value and y sub 1 for your first y value. Here, the first number in the sequence, and a lot of times in all sorts of physics courses or computer science courses, the beginning of a list is the 0th element because we start numbering at 0. So we call this A sub naught, A sub 0, representing that's the first element in our sequence, in our list. Okay, the A naught. And then we also have to have, what is the, like, if me and you were talking about the 5, what would you call the 5 in this? That's telling us how much we're increasing every time. Yeah, that's the way me and you would talk about it most likely. When we have a linear equation, we would use slope. That every time x goes up 1, the y goes up 5. When we're talking about it in terms of a sequence, we don't really use the word slope. but it works kind of the same way. It's called the common difference. Okay, and here is our formula for an arithmetic sequence. A sub n. This means if I'm trying to find the nth element in the sequence. So like on July 2nd, that would be your A sub 2, right? That's your second element in the sequence. If I was looking for the 5th, it would be A sub 5. So the n really represents any day in the sequence. It's equal to A sub naught plus the common difference, your slope, times n minus 1. So think about, if I wanted the first day in the sequence, right, I would plug in a 1 here. And so everywhere there's an n, plug in a 1. So what is 1 minus 1? 0. 0 times 5 is 0 plus 15. So the first day is 15. For the second day, you could plug in 2 for n. And for the third day, 3 for n. And so on and so forth. All right, our formula for an arithmetic sequence. Okay. Now, let's look at the bottom, the part where we're kind of looking for a strategy to figure out how many miles David, Isaac, whoever, ran. So here's the way that they talk us through it. On July 19th, we could start with a base value of 7.6, and then we could add 0.2 one time, because that's one day past the day I know. Right? This one was 4 days past the day I know. So I would multiply 0.2 times 4. Another way you could think about how I got 4, I subtracted the day I was on minus the first day that we started with. And then if I had to back up and go to the 15th, if I did 15 minus 18, I would subtract 3 from 0.2. Right? This is probably what you did in your heads. You just didn't write it down. You didn't verbalize it. So if you want to think about that formula to find your sequence for any day, it can be equal to any term, a sub k. It doesn't have to be the first term in the sequence. It could be any term in the sequence. Plus the common difference, in this case that is 0.2, times n, whatever number day I am starting with. In this case they were all 18. No, I'm doing it backwards. So for us, our K is 15. 18. What day do I know? 18. Okay, so for us, the K is the 18. And the N is what day I'm looking for. So in each problem, that would have changed to 19, to 22, to 15. Do you follow that? This is kind of weird. Man, I told you these are weird. They're not really going to carry over. It's going to be done today once I get done with it. So now when I look at number 6 now, could we figure out how many miles David ran without knowing how many miles he ran on July 1st? Yes, this formula allows me to do that. Right? Does any of this talk about the first day? A sub 0, A naught? No. So we can do that by taking the known day and then adding or subtracting the day you're looking for. Okay. What about that? I'm going to put the notes up, and then we'll use the rest of class to work on the check your understanding. Again, these notes, use them however you want to. So it says a sequence is a function whose inputs are the positive integers. All that means is it's the first term, and the second term, and the third term, and the fourth term, and so on in the sequence. So you can't have any fractions or decimals. You can't have any negatives. We always start with the first term. An arithmetic sequence has a common difference. And then the rule for finding the nth term. So we've got, they use a different, like they use a sub 1 for the first term, which I've not ever seen this be a sub 1. I used a naught here. But again, different textbooks have different, like, I don't know what they're talking about here, but I don't know what this a naught would mean. Every textbook and every teacher I ever had when I learned about sequences, we always took the first term as a naught, not as a 1. Again, every textbook